A rain gutter is formed by bending up the sides of a 38-inch rectangular metal sheet as shown in the figure below. Part A says to find a function that models the cross-sectional area. So what you need to know is that the area of a rectangle is the length times the width. So for this particular problem, it told us that it was, our width represents this total distance across. So it was 38. But what happened was we took a side of x and folded it up on both sides. So now what we have is our length in terms of x, 38 minus 2w, times our width of, and they're using x, so we said 38 minus 2x times x. So once again, the whole sheet was 38, but you took and folded up both sides. You folded it up here, so you subtracted that part off. You folded that up here, you subtracted that part off. So 38 minus 2x times our width of x. So you could multiply it out, or you can write it just like this. So if we multiply it out, you have 38x minus 2x squared. Part B says find the value of x that maximizes the cross-sectional area. So whenever you have a quadratic and you see maximize, you need to automatically think of vertex. So the formula to find the x-coordinate of your vertex is negative b over 2a. Then to find the y-coordinate, you plug in negative b over 2a into your function. So part B just asks us for the x value. So x is equal to negative b over 2a. And remember, the standard form of a quadratic is always ax squared. So a is the value that's in front of the x squared term, your leading coefficient. B is always the term with the x. So it's 38 in this problem. So you have a negative 38 divided by negative 4. And if we reduce that down, we can reduce both by 2. Or if you have a calculator, you can figure that out as well. So 19 over 2, which would give us 9.5. That's the value of x that maximizes the cross-sectional area. So that's what the width in the problem, or the length in the problem, needs to be. Then for part C, it says what is the maximum area. So you want to know what is that actual value. So you take your function and you substitute in the value of 9.5. And plug all that in your calculator, and that will give you the actual maximized area.
Made with Doodlecast Pro.